All right, let's look at the practice exam 3, problem number 6. All right, so let's see, we have a force field given here, and it's acting on a particle that moves along a line segment from 0, 0, 1 to 3, 1, 0. All right, so let's find the parameterization for this line segment. All right. So starting point has a coordinate 0, 0, 1, and ending point has a coordinate 3, 1, 0. Right? So we try to come up with a vector from the starting point and go straight to the ending point. So I'm going to call this vector v. Alright, and the vector v can be easily found by just ending point 3, 1, 0 minus the starting point 0, 0, 1. Alright, so this is going to be equal to 3 minus 0 is 3. Actually, this is a vector, so I'm going to write it as a vector notation. 3, 0, so 3. 1 minus 0 is 1, and 0 minus 1 is negative 1. Right, so this is the vector. Right, so what we can do is we can parameterize this line segment by starting from the starting point. So you have a 0, 0, 1, and then you add the multiple of this basically a direction vector. So we have a 3, 1, negative 1. Right? So when t is 0, you are at the starting point. When t is 1, you are at the 3, 1, 0. All right, so you can see that, let's see, first component is 0 plus 3t. So you're going to get 3t. And then you have a 0 plus 1t, so you get the t here. And a 1 plus negative t, so you have 1, so 1 minus t. All right, so we got that. All right, so that's the parameterization for the line segment. All right, let's look at the part B. All right, so we want to set up a line integral for the work, so which is given here. All right, so here you have F. This is the force. All right, so along this line segment, so we have to plug in. So this is the x value, and this is the y value. This is z value. All right. So first component is x minus y squared. So x is 3t, so you have to put the 3t here. All right, minus y squared. Y is t, so this is going to be simply t squared. Second component is y plus z. So y is t plus z is 1 minus t. So t and the negative t cancel out. You actually get 1 here, which is nice. All right, then the third component is x plus z. So x is 3t and z is 1 minus t. So it's going to be 2t plus 1 because you have to add them up. So you have 2t plus 1. All right, then we need to have a derivative of this parameterization of the line segment. So derivative of 3t would be 3. Derivative of t is 1. Derivative of 1 minus t is negative 1 dt. All right, then t is going from 0 to 1. So 0 to 1. All right, then we just have to evaluate this. So this is going to be equal to, all right, so we have an integral from 0 to 1. Right? So this is a dot product, so it's going to be 3t minus t squared times 3. So you have 9t minus 3t squared, right, plus 1 plus 1, so 1 times 1 is 1. All right, so then you have a 2t plus 1 times negative 1. So it's going to be negative 2t minus 1, right? And with respect to t. All right, so we can cancel positive t and a negative t, positive 1 and negative 1. And we can combine 9t and negative 2t. So you have an integral from 0 to t. All right, so 9t minus 2t would be 7t. And we still have a negative 3t squared. Right, with respect to t. Right, take the antiderivative of 7t would be 7 over 2 t squared minus, right, 3t squared antiderivative would be t cubed, right? And then you're going from 0 to 1. Right, so this is going to be you plug in 1, you get the 7 halves minus 1. And if you plug in 0, it's all 0. So you just get that. So it's going to be 5 over 2. Right? So the work done by this force to the particle is 5 halves. All right, that's it. I hope that this was clear.